Welcome, everybody. Welcome back to the Additive Snack podcast. This is our series on consumer and sporting goods, and I'm your host, Fabian Ahlefeld. Today, we're covering another leader in the space of additive manufacturing as we delve deeper into the world of AM and how these technologies are transforming industries, especially in this case, the industry of the sporting goods. Today, we have Thierry with us. He's the engineering manager for advanced product development at Bauer, and he's focusing on protective equipment and protective products. And if you don't know Bauer, Bauer is a pioneer in hockey gear. Thierry, it is so great to have you on the show.
Fabian, thanks for having me. I'm glad to be here.
Thierry, we've talked before, and I think your journey into additive manufacturing actually goes back quite some time. Can you tell us a bit more about your first exposure to additive and how that kind of shaped your way of thinking?
Yes, I was always a lot involved in all the, I would say, the R&D side of thing and development. And at school in 1999, I chose one course that was everything about doing rapid prototyping.
Mm-hmm.
And we see all technology like casting, doing silicone molds, all the stuff. And they have a small part or a small section that was like rapid prototyping at the time with additive manufacturing. And the technology was LOM. So it was the big thing. I remember a big table with how do I choose the technology? And they were saying that when the part is 25 millimeter by 25 millimeter by 25, choose additive manufacturing to do it. So we're far from that study that we did at the time.
Interesting. And for those who don't know millimeters, that's roughly 1 inch cube, right? Which is tiny.
Exactly.
Yeah. And then, so after college, your exposure to additive didn't stop, if I remember correctly, right? You also worked at a company called Mission iTech, and you had some additive projects there as well.
Yeah. So at that time at Mission iTech, it's another hockey company, and I was in charge of helmet and goalie mask.
Mm-hmm.
So we had the project at the time that we need to revamp like the look of the goalie mask. And the goal was doing that with additive manufacturing. And that's why I bought my first machine. So it was a FDM machine. It's a dimension. So it was a old one, and we still have it actually since 2008 that we play with it. So it was a great investment.
Yeah, interesting. And can you explain to me just briefly why additive manufacturing is suitable in this case for a goalie mask, especially for those people out there who are not experts in hockey?
So when you design a new product, you want to do prototypes or mock-ups of it. And when you're changing a lot the look of the iconic goalie mask, the goal was to like keep the iconic look, but bring fresh new design in it.
Mm-hmm.
So to do that, we need to do the prototype. So instead of carving by hand, by clay, we have decided to go and buy the machine to be able to iterate faster at the time. So it was more for a see and look of the design and not like a functional part at the time.
Yeah, we've come a long way, and you've come a long way as well. So let's talk a bit more about Bauer. How did you end up at Bauer, and how did Bauer and yourself start to explore additive manufacturing outside of the prototyping realm, but truly for end-use products?
Mission iTech was acquired by Bauer in 2009. So that's why I joined the Bauer family. So when I arrived here, there was a couple of machines, but we brought our FDM machine with us. Since then, we bought 5 more in total. So we have plenty of machines. So we have now all the technology available for us, from filament to liquid and also powder, that we can do prototyping. But the more we go in time, the more we want to do something better with the parts that we produce. So that's why we want functional parts that we can like play hockey with it or do testing with it. So that's why we went and decide to, okay, what's going to be like, we're looking slowly at how we can bring like parts on a hockey gear.
Mm-hmm. Okay. So the transition was actually quite natural. Out of prototyping, you guys got more and more experience with prototyping. The technology was advancing. And then there was a point where, if I remember correctly, you realized, hey, we have to do this now. Can you talk about
Yeah,
this moment?
yeah, that was a magic moment, I would say, that in terms of R&D, when you're a guy that is love doing R&D stuff and developing. I had a visit, like I would say around 2018,
Mm-hmm.
from probably someone that you know, that's John Walker,
Mm-hmm. Yeah.
works at EOS. So he came in and so the first goal of the visit was to meet with the skate team and say, oh, can we do like footbed for skate with you? Maybe there's a good opportunity. So I was invited to the meeting since I'm curious and would like to know something new. So John brought a lot of parts, and I was looking at parts, and I had one part that I was playing with for all the meeting. So I still have it. I still have it. So it's that part that I was like playing, squishing, twisting. Say, oh, that's so interesting. The hamster was running, and I say, oh, that could be great for helmets. But so that was what was in my mind. So we went through all the product at Bauer, and we realized that through the product, it was not necessarily skate or like body protection, but say like shoulder or something else. It was really the helmet that was probably the first focused product that we should work on.
Mm-hmm. And for those listeners who are just listening through Apple Podcast or Spotify, that part that Thierry was just referring to is a digital foam piece, meaning a soft polymer lattice structure that is quite squishy and I think opened up that whole opportunity that we're now talking about. If I remember correctly, you immediately went to your boss and said, hey man, we gotta do this, right?
Yeah, totally. So I say, I found the next thing. I think we should go with that and go full steam with it. I was ready to buy a machine like the day after.
That's awesome. I like that enthusiasm, and it really shows the innovative power that gets unleashed when people get exposed first with additive, where the gears start turning and the creative mind starts to work. But you also, I'm sure, realized pretty quickly that it's not a plug and play technology. How did you go about educating yourself and starting to think about how do we truly implement this technology as a production technology?
So I think that the timing of that visit was quite amazing because it was like early January, I would say, and the show, let's say, routine was starting. So I went to 3 shows that year. Let's say the AMOG to the Rapid to the Formnext to learn more about technology.
Mm-hmm.
And I know if it's like life or coincidence, but 2 weeks after like John's visit, like I had a visit from a rep from HP
Mm-hmm.
that was showing me their new technology. Say, okay, there's probably multi-company that I can like scratch with and try to find what's going to be the best solution for us. And by visiting the show, I met like Carbon.
Sure.
That was very interesting when they were showcasing the footbed, not the footbed,
The football helmet.
the midsole. Yeah,
The midsole. Okay.
they were the midsole of the shoes for Adidas. So okay, that's okay. There's other company, other possibility, and so I realized that I thought I knew a lot about additive manufacturing, but I was knowing so little.
Mm-hmm.
So it was a long journey of learning all the next step that you need to do to be able to try. So we did a lot of trial with Carbon, we did with HP. So a lot of company to evaluate technology, machines. And since we are here in north of Montreal, it's an innovative center. So
Mhm.
it's an R&D center. So we have our own lab. So we do our testing. So we test foams every day, but those lattice were new, or so the goal was to like compare that with what we knew. But at the same time, it was so new that so many possibility of the lattice. That's why I test all the technology to focus on one
Mhm.
at the end.
Okay, Thierry. So you saw all those different technologies from HP to Carbon to EOS and probably even others if you went to all those big shows like Rapid and Formnext and IMTS most likely if it was that year. How did you make a decision on a technology? Because that can be quite overwhelming. And some people have the biggest Excel sheets you've ever seen. Some make a gut decision. How did you make that decision?
Yeah. So when I was looking at all the different technology and all the testing that we were doing in our lab, I realized that for me, there's one technology. So let's say that all technology have goods and bads, but for me, one technology that was standing out, it was the powder-based technology because of the freedom of design.
Hmm.
So I could design very complicated stuff without having to take care of removing like supports or part orientation. It's totally true, but let's say less true with the powder. That part orientation I can create undercuts or stuff that you cannot create necessarily with the liquid or with MDM.
Okay. That's super interesting and a really hard decision. And now you made a decision and had to sell it internally and figure out how do we now implement this? We know which technology we want to bet on. How did you move forward? What was next?
Yeah, so just to say, it took me almost 3 years just to find out or decide, okay, which going to be the path for the future for Bauer. So when that decision was done, we always have innovating meeting each year. Like we present what's the innovation. So through prototypes, through showing all the capability of, let's say, the technology and the next step. That's what I did to convince people. So at first I did have the powder machine. So what I did, I was using our MDM machine to create like liners to bring to people to try. And so the goal was to leverage, let's say, the helmet category. So the next step for us was the custom liners. So create a liner that fits your head properly.
Sure.
So better than regular ones. Not
Hmm.
that they're not fitting, but they better than regular ones. So a helmet specially made for you. So that's how I convince people with my internal machine to the next step to buy or to acquire all the machine that we need to print those helmet or those liners.
Okay. So you went from this exciting moment, the magical moment you were referring to, realizing additive manufacturing is more than prototyping. It can be a production technology. And pretty quickly, you actually went to that helmets, if I remember correctly. You then did your due diligence in understanding all technologies, which are the upsides and the downsides of each technology, and which fits our application that we're targeting best. And then you did the
Yeah.
most difficult part, actually, or one of the most difficult parts, which is getting internal buy-in, creating this whole project plan and story, and convincing your internal team. But now the actual work really starts. You secured funding, you have a good application identified, you know what you want to do. Now the development starts. Can you talk us
Yeah,
through those process steps?
totally. I think what is key when you do R&D in general, but for that project was your partners. Those are very important, that partners that you can rely on, that you can work with and try to push everything to the next level. So yes, we have choose the powder bed, but we quickly realized that the surface finish probably was not totally okay because it was itchy a bit. So we realized that we need extra machine to be able to smooth the surface and probably dye the part. So that's why we went with Dimension. So
Hmm.
we look at some other company, but Dimension was our company that we choose to finish the processing the parts. So I think it was great, but that was only like a small part of the equation.
So, Thierry, you guys went through a very diligent process of identifying the right technology, the right application. You put together an internal business case and convinced the rest of the organization that additive manufacturing has a huge potential for you. What was next? How did you now do the difficult part of the implementation, which is defining the process chain and getting into production? How did that happen?
Yeah, it's true that it's a process. So since we start from scratch, not even from technology, but everything around that. So I always try to go with great partners. So I always try to have not only a business relation, but it's a partnership relation that I'm looking for. In every section of my work, that's what I'm trying to get. I found that with EOS. But after that, when we saw the first few parts, we realized that, so we still need to do something with the surface finish because it was a bit rough for the forehead.
Mm-hmm.
I met the dimension people at those shows and realized that, okay, that's what we need. So we try to avoid smoothing everything, but we realized that it was bringing something to the product. So we went also with, after the printer, it was all the post finishing.
Mm-hmm.
So how we like smooth the surface and how we can embellish it. So we also dye the part. So we bring colors to that. So could bring us a lot of things for the future. We can change color for the themes or something like that. So it was a good side business. But
interesting.
So when you create the liner, so there's a lot of stuff in front.
Mm-hmm.
So you need a scanner to scan that. So we went with Twikit.
Mm-hmm.
With them, we developed all the forefront. So all the apps for the scanning up to bringing like the scan of the head to our system.
Sure.
So when you create your 3D liners, you also need to put the lattice in it. So I try many software. So it's a lot of possibility, different company that I met. But since we are R&D company, we like to get in control of what we're doing. We want to do a design ourselves. So from the software, I try from Grasshopper to Element from the first version of hand topology software. We went at the end with their last software, Entop. For us was the most powerful software to create the lattice for our helmets. So
interesting.
Very convenient. So from the scan to creating the liner, to print them, to finish them. And after that, there's a whole ecosystem with all the Shopify that we need to create to be able to print them and send them to the right location also, that it was a full ecosystem. So all the company was working on that.
Yeah, this really showcased that additive manufacturing is just a piece of a whole value chain ultimately, right? And thank you for also naming all those players, right? You have Twikits that takes the scan in, you have Entop for the lattice design, then there's Sprint in there for print preparation, you print it on an EOS machine, you post-process it on a dimension system, and then there's additional supply chain activities happening and assembly activities within Bauer that I'm sure you also need to integrate into this whole value and supply chain.
Yeah, totally. So you know that a lot of companies, they produce overseas.
Mm-hmm.
So we need to bring our base helmet from overseas, but everything is print here in Blainville. So the final assembly and the testing is done here in Blainville. So it's a logistic of everything that comes at one place and go out to the customer.
Super cool. No, I think this is the type of application that Additive has really been waiting for, because it really plays into all of the benefits it can offer, from customization to performance improvements to supply chain and reshoring benefits. It really touches base on all of these. And I think you have a helmet with you. Can you show it to us?
For sure. That's that's our helmet. So let me just try to find the best angle. So are you able to see it correctly, Fabian?
Yes, yeah, we can see it. And we'll explain it for the listeners as well.
Okay, so all the blue parts are printed liners for the front ear and the back. Okay, so that's the approach that we choose for the first helmet, customizing the front and back. So to make sure that it's fitting properly, the forehead, I think that's a more critical part of it. So a lot of challenges over there too. Let's say that if everyone was like me, no hair, life will have been way easier for Bauer. But since we have people with hairs, we need to take care and consideration their hair. So sometimes the scan are not totally clean. So we need to process them and to make sure that the helmet's going to fit properly your head.
Interesting. Yeah. And for the listeners out there, so ultimately, Thierry just showed a hockey helmet. And within that hockey helmet, there's pieces that are conventionally standard foam that are now 3D printed lattice foam replacements that are based on the user's scan of their head and therefore have a perfect fit. And you mentioned that the fit is some challenges, but what are the benefits for the end user, for the athlete that you're trying to achieve?
I would say so. The first obvious benefit, the fit, which when you compare to regular helmet, so that helmet, it was based on the React 150 that we still are offering. But that you said, Fabian, those are made with foams. But players, they used to get pressure point when they put helmets on.
Mm-hmm.
We accept pressure point because that's what it is for decades. But when you put that helmet on and it's fitting correctly your head, at first you're not sure if it's fitting correctly. So you feel that you don't feel any pressure point. That's super weird. So, but it's an amazing feeling, but at the same time it's weird. So I remember the first few people that tried the helmet, they were squeezing the helmet on their head like crazy, saying, no, you need to wear it snug. So it's following the shape of your head. So you should not feel anything. So that's the first thing that it's a game changer. The other thing I would say that since we use lattice as not foam, so we used to get foam that's touching your head, and there's a lot of heat building in the helmet when you play hockey because you sweat a lot. The dissipation from the lattice was like a good benefit that came by surprise. We didn't know at the time that would happen, but we know that when they overheat, they perform less. Now that they can have heat extraction from the helmet easier. So for sure on the ice or when you're on the bench, you're going to be fresher to go on the ice and perform at your best.
Yeah, that's such a funny story that athletes were uncomfortable because they were too comfortable because it fit perfectly. Interesting.
That's something that no one knows before that.
Yeah. Yeah. And also shows the power of additive in that case, because it allows you to also rapidly innovate. And hence, if there would have been an issue, you could have changed it quite easily because you have that whole digital workflow in the front end, which starts from a scan and ends with a post-process part.
Totally. So since we still like tweaking some people to make sure that they have the perfect fit. So we try to get a flow that it's almost fully automatic. So with less end user that we put energy in, that's it.
Mm-hmm.
But sometimes we have special cases that we stop the machine and say, let's take care of that helmet, like that special one. And we like put more work to make sure that the fit is perfect.
Okay.
Because that's what we want to offer. Helmet that fits you the best, a good fit for you. It's like a good protection too. So we don't want to bring a custom helmet that's not fit you properly. So it will defeat the purpose of the fit and like the better protection when you get something that it's fit correctly.
Yeah, 100%. If it's custom, I want it custom. So that's really good that you guys also put that customer support and customer success management behind it. Now, the helmet launched last year for the previous NHL season. If I understand correctly, there were even some cups won with that helmet. Is that correct?
Yeah, totally. We have a Cal McCarr from the Colorado Avalanche that won the cup with our helmets. He won the Connie Smythe too, so the most valuable player of the series. So I think it was a good thing for him and for us.
Yeah,
that it was able to wear the helmet during the playoffs.
Okay, so NHL, those guys get to wear the helmets. What about the rest of us? What about our listeners? What about additive enthusiasts? And what about hockey players that now want that perfect fit helmet? How do they get their hands on it?
Yeah, so we have deployed worldwide over 300 scanners. So everywhere where Bauer's distribute, so there's a scanner for you to get scanned. So you can go on Bauer.com and you can find some of those dealers that can scan you. But from Europe to North America to China to Australia or New Zealand also. So you can find someone that has the Game Fit application that can scan you and you'll get your custom helmet for you.
Wow, that's incredible. And when does that start?
We start that, I would say, late October, early November last year, but it's become it's pick up a bit more, I would say. So it's like we're receiving our more order now, since that the word it's spraying around a bit more, I would say.
Mm.
But let's say that the order is not piling, but it's coming in as we expect. It's great. It started last year, but seems to get pick up a bit more this spring.
Awesome. And yeah, hopefully after this episode airs, we also have some more pickup. Thierry, thank you so much for sharing all of your experience and your insights with us. This was such a great episode to understand the process going from idea really all the way into production of a quite complex product, right? Because you do have to build that whole process chain on the back end. And I appreciate you being so open to us and with us. Thanks for being on Additive Snack.
It's my pleasure. Thanks for having me, Fabian, and I hope I'll be able to do another one with you.